Let's go ahead and verify these two problems here. And the reason why these are examples from calculus is when you take calculus next year, you're going to find that when you're able to rewrite trigonometric functions as more complicated, meaning like, why would you want to write tangent to the power 4 as tangent squared, secant squared, minus tangent squared? It seems like you want to leave it this way. But when you start doing integrals and so forth, it just makes it a lot easier when you have them in this form. So you'll find that out next year and how it's much more helpful. So we're just going to verify that really this tangent to the power 4 really is tangent squared, secant squared, minus tangent squared for this problem here. Okay, so let's look at the left side. And tangent to the power 4, okay, again, let's just remember, you can think of tangent to the power 4 as x to the power 4, right? And x to the power 4 is the same as x squared times x squared. So that's what I'm going to do right now. I'm going to rewrite tangent to the power 4 as x squared times x squared, or in this case, tangent squared times tangent squared, all right? So tangent squared of x times tangent squared of x. All right, so I'm just replacing tangent to the power 4 with these two guys, that product. Now, tangent squared, I'm going to leave this guy alone, okay? And I'm going to replace tangent squared with our Pythagorean identity, which is secant squared minus 1. And if I now multiply this through, tangent squared times secant squared is tangent squared times secant squared. There's supposed to be a 2 there, of x, and then minus tangent squared times 1 is tangent squared of x, and that's the same as that right there. Okay, come over here to the left side. Let's go ahead and verify that this guy's going to be equal to the right side. Okay, a little bit of tricky here. I'm going to break up my sine cubed as sine, let's see here, sine squared of x times sine of x. That makes sense, right? I mean, sine squared times sine is just sine cubed, all right? And then we tack on our cosine to the power 4 of x. Now, I can replace my sine squared with our Pythagorean identity with 1 minus cosine squared of x. Okay? And then we still have our sine of x, cosine to the power 4 of x. All right, so we're almost right here. What I'm going to do is I'm going to leave my sine on the outside, and I'm going to go ahead and distribute this cosine to the power 4. So cosine to the power 4 times 1 is cosine to the power 4 of x. And then cosine to the power 4 times negative cosine squared is a minus cosine to the power of 6 of x. So close those in parentheses and leave the sign on the outside. And I know I want to do that given that I'm looking at what I'm trying to verify. And as you can see, these two are equivalents.